All right, we should be live for Royal Quan office hours. Let's see who's joining us. All right, let's see who is joining us today for office hours. There's that bonus question we want to get to. That bonus question that we would like to get to. Right, so I go up to mini projects. I go into NLP. Remember, we built our own custom class that did that polarity for us. I see Mickey, I see Esau. I thought that was a kind of interesting thing how we came up with this idea. We saw Suleiman coming to us from Nigeria. We saw, you know what, it'd be nice if the naive Bayes model in scikit-learn can do some polarity analysis. And we said, you know what, let's take what we built and let's do that. And that's exactly what we did. Exactly what we did. We create our own class here, inherit it from multinomial NB. No need to reinvent the wheel. All right, Esau finally got past the error from yesterday. It's good to hear. I see Raymond is here. I see Anas is here. Welcome, everyone. And now we define the additional methods that we would like to do the polarity analysis. That made it a lot easier to implement that. So kind of using things you learned in the previous unit, inheritance, we improved on something. I see Renato is here. All right, welcome, Renato. All right, so let's look on Q5. It's ungraded, it's optional, but why not tackle it? Let's see what this is all about. Topic modeling is analysis to determine the key topics or themes in a corpus. So you can imagine that we have a corpus of all these electronic reviews. And previously in this notebook, we've been mostly doing supervised learning. Predict the ratings, and then we also looked at polarity, sort of an introspection. But why not do some sort of topic modeling? Why not let's take that data and try to figure out some of the dominant topics or themes that are being discussed on these reviews. So it's an unsupervised learning technique. And let's see how we can achieve that. Let's go and see how we can achieve that. So remember, we have here is our reviews. Reviews come in here. Then what comes next is our vectorizer, right? It's going to vectorize our review. We have now each review, each document is a vector in a p-dimensional space. Now in the back of words model, what are those features that we create? We create features, but what are those features in the back of words model? What are they? Can you describe those features? What are they? What are those features that we create in the bag of words model? Words, exactly, right? Words. Our features are words. Now, right, we have our vectorizer, and we might have the next step. Exactly, so I mean, words. The features are words. Now, let's think about what would happen if I were to compress my space. My vectors, my documents exist in a p-dimensional space where p are the words, right? The counts are the actual values of those vectors, of those features. The features themselves are the words. Exactly, Mickey. The features themselves are the words. The counts represent the value at that coordinate, the value at that feature, the value at that dimension. Now, what if we apply some sort of, we compress our space? What if we have our data that exists in a p-dimensional space, but now let's represent it in a lower dimensional space represented by m features. This here is the realm of unsupervised learning, specifically of dimensionality reduction. Dimensionality reduction is all about, I have data in a p-dimensional space. How do I represent it in a lower dimensional space but yet still preserve the bulk of the variability in the data. That's what dimensionality reduction is all about. Right? How do we come up with new features so that those new features can still describe the bulk of variability just using a smaller subset? So in some sense, we want to apply dimensionality reduction on our data. So what we want to have here next, is some sort of dimensionality reduction. I'll call it step DR. Dimensionality reduction. So instead of representing our space using P features, we will represent them using M features. Questions so far about what we want to do for this optional question, what we're trying to build up to? Okay, so we're going to do dimensionality reduction. But well, how does that tie with some sort of topic modeling? Well, remember what we did with PCA. In PCA, we came up with new features. I'll call that new feature V1, which is composed of a linear combination of my old features. Remember, that's what we said for PCA. We are representing our data using P features, and these new features are simply a linear combination of the old features, where each old feature is weighted by a coefficient. So what we're going to do here is the same thing with dimensionality reduction. We're going to go ahead and compress our space. Instead of representing our features, our data using P features, we're representing using a truncated set of M features. And what we'll do is we're going to look at the coefficient in front of each of those features. Because that coefficient in front of those features tells me how much does the old feature contribute to the new feature. Remember, that's what we did for dimensionality reduction. We can quantify how much do those old features contribute to the created new feature. And the reason why we want to do this is because for every new feature we create, we want to figure out the top, let's say, 25 words that make up that new feature. Remember, because our features, our old features, are words. So I can look at the top 25 words that contribute to that new feature that I create through dimensionality reduction. And hopefully, I can look at those top 25 words and derive some sort of semantic understanding. In other words, can I look at those words and can I make sense of it? And can I treat that as a topic? Because instead of before, I would represent my data in using a feature space of words, now my new feature space is a collection of words. And I can call a collection of words as a topic. And that goes into this idea of topic modeling. Questions about the theory of what's going on before we implement it in scikit-learn. All right, let's try that out. So we're going to use non-negative matrix factorization as the way we're going to reduce our dimensions. And the reason why we're using non-negative matrix factorization, it's a variation of PCA. It's a variant of PCA that's going to preserve the non-negative aspect of our training data. If we're dealing with counts, we have non-negative data. Or even if we're dealing with data that was derived from counts, like a TF-IDF vectorizer, we have non-negative values in our data. We want to preserve that non-negative feature and preserve that non-negative characteristic, I can say. I don't use the word feature because we use the word feature to mean something specific in ML. We want to preserve that non-negative characteristic in our data. So we're going to use the non-negative matrix factorization model. I'll go ahead and run. Let me go ahead and see. Let's see, are we doing this on what data? It's not clear whether we want us to do it on the original data or the subset. Oh well, we'll have to just choose one and go with it, right? It's ungraded, so what's the worst that can happen? The worst that can happen is our kernel crashes. That's really the worst that can happen. At least the worst likely outcome that can happen. Let's do with our polarity data. How about that? All right, kernel, restart and clear output. I'm going to go ahead and run this here. Get my data. Doesn't know what gzip is. Okay, that's fine. We'll import that right there. Name error, doesn't know what JSON is. No problem. Import JSON. We got our polarity data. Okay. Let's go and start setting up the pipeline. So our pipeline would be simply the vectorizer followed by the dimensionality reduction step. So from sklearn, pipeline, import our pipeline class. And from sklearn, let's import a vectorizer. Let's use TF-IDF vectorizer. Okay. Let's go and construct our pipeline. I'm going to call this pipe, pipe or model topic. Create my pipeline. First step is the selector, if I recall. Two frame, actually the converter. I probably need that converter. Go and run up here and run that cell that defines the converter. Just modify my workflow there. First step will be my converter. My data converter. Next step will be my vectorizer. Well, I kind of set that up, right? It's going to be the column transformer right there. So let me make sure I import my column transformer. Compose, import column transformer. And my step would be the vectorizer followed by the TF-IDF vectorizer. And let's apply it to the review text column. And then the dim reduction. Non-negative matrix factorization. We have to choose the number of components we want. In other words, how many of these new features we keep. And I'm just going to say 20 right now. We can always adjust that number. I'll put 20 right now. And then, since this will probably take a while, let me just fit it right now. Questions people have about what I've worked on here. The workflow, very similar to what we saw before. Convert it into a data frame. Apply the vectorizer. Apply dimensionality reduction. Questions about what we have coded up here. That finished running, so that wasn't too bad. Okay. Well, nothing really has happened just there. Nothing exciting, right? Let's do the introspection. What I'll do is I'll take my model and I'll look at name steps. It gives me the dictionary that maps step to the transformer, to the estimator. I misspelled dimension. I'm going to be very picky, so I'm going to go ahead and rerun this cell here, my dim reducer. I'm a little annoyed how I misspelled that. So we don't fit on ratings. Exactly, right? Exactly. We don't fit on ratings because we are purely, this is purely unsupervised learning. No use of ratings. Labels. What we're doing is we're reducing the dimensions of our data. We took our data, we vectorize it, and now we're reducing it to 20 dimensions. Purely unsupervised learning. Other questions you will have? Okay, do let me know. So in our dimensional reduction, there's an attribute called components. Okay, that seems to be a NumPy array, and it is 20. Look at this here. Why data polarity? Just for a design choice. I guess I needed to train it on some data. And I said, you know what, let me just train it on the data where I've looked at the polar reviews. We can always go back and train it on the full data set, but I decided to, right now, let's just train it on this subset of data that I pulled out. Probably easier to get up and running, but nothing more deeper than just, hey, it's there already, it's a smaller data set, let's try it out. Nothing more beyond that. So this is a NumPy array that has 20 rows by 2,517 columns. So over close to 26,000 columns. We have this data set. I'm going to call this data set, I'm going to call this NumPy array phi. I'm going to call this phi. So now I have a data set that's by 20 and by close to 26,000. Okay, well that's interesting. Well, then we might want to ask, well, how many words or how many features do I have in my original space? Well, that's probably stored in my vectorizer. We saw yesterday or the previous days that if I want to look at how many words I have in my data set, or the words that were counted more precisely, that's stored in the vectorizer. It's a model topic. Then I can look at the vectorizer. There's a column vectorizer. I always forget the name of the attribute that I can access these steps. So I can call dir. And let's see. Named transformers. Well, that's probably what I want. Access the vectorizer. And now I can say, well, get features, get feature names. Well, that's the mapping. Let me take the length of this. And I have the match. So what I've done here is I looked at my vectorizer and I looked at how many features my vectorizer generated. My vectorizer generated close to 26,000 features. It matches exactly with the number of columns of this phi NumPy array, this 5 matrix. So okay, well what exactly is this phi matrix? I have 20 rows. Well, I told it to choose 20 components. And it looks like the number of columns of that matrix corresponds to the number of features my vectorizer generated. What this means is phi is a matrix that tells us how much of each old feature contributes to the new feature. So each row is a new feature. Each column is an old feature. And the value is a measure of how much that feature contributes to that new feature. And remember what these features represent. If our old features represent words, then I can take that last sentence I wrote out and express it more concretely. I can say the value is a measure of how much that word, because old features are words, that word contributes to that topic. Remember what we said. Words, collection of words can represent a topic. So this matrix here is going to tell me how much each word contributes to each new feature, and each new feature is a topic. So now I can play around with this matrix and derive some sort of insight. Questions people have up to this point here? All right, do let me know. Do let me know. So what this means is that, well, let me take row 0. Let me take row 0. And then let me go ahead and look at the indices that have the largest value. Right? I can take phi and take a look at row 0. Lots of zeros. In fact, let me just compute the sum. Well, there's some non-zero values in there. Don't worry, there appears there's some non-zero values. But what I can do is I can figure out the indices that have the largest value. Right? What I want to do next is I want to for row 0 or new feature 0 or topic 0, find the indices with the largest value, which is like asking what words had the biggest, most impact to that topic. So if I want to figure out the indices that would, I want to find the indices that have the greatest value in this vector. Well, I already know how to do that. I saw that yesterday or a few days ago using the argsort method or the argsort function. Argsort. And I probably should say reverse equals true, since I know it does it by ascending order. I get an error because I may not have that argument there. That's fine. Let me just look at the documentation. I don't have argsort memorized. I don't use it on a daily basis. Let's look at what I have to do. Kind, order. There may not be an option to specify how to sort it, but let me just double check because I thought there was. Let's see. No, I can choose the type of sorting technique. No, but that's fine. I know the last ones. I take the last 10. And these are the indices with the largest value for that row. I can kind of do some spot checking just to make sure. Max. Okay. So that means that this index should be that value. So phi, and I can say 22690. I get the same value. Okay, so once again, I do some spot checking. It seems to be making sense, seems to be working out. So what I can do is I can figure out, these are the top 10 old features, words that contribute to my new topic. Then once again, I've got to figure out the mapping, right? Once again, I can look at this output here. And call this into word or into feature, into word. And now I can say into word and say, give me the word that's 22690. It's the. Not too interesting. I probably should have used stop words. Oh well, I can always go back and fix that. It's of. The next topic is of, right? Sorry, the next word is of. It's in. And well, at this point here, it's a bit tedious, so I can probably just write a for loop, right? I can do a for loop for that. So I can say maybe for I in here, print out into word of I. Syntax error, so I have something fundamental for I in, right? And there it is. There's my first topic, my very first topic. Not the most interesting things, right? I got a couple of words, several words. Now it's my task, my job to derive semantic understanding here. Anyone want to take a stab at some sort of semantic understanding from this topic 0? I'm struggling here, so what are people's thoughts? Semantic understanding behind topic 0, if any. You can choose the top 25, top 20 words. I'm guessing these are probably what should be stop words, right? Not the most interesting thing. So let's try out a new topic. Let's try topic 1. Let's see the top words that contribute to that topic. So what type of semantic understanding can we derive from topic 1? Any guesses? What are your thoughts? Wide, zoom, images, cap, 18, light, Nikon. What type of semantic understanding can we derive from this topic? Looks to be maybe lenses, right? Okay, so it looks like Mickey tried with the stop word. So let me try that. Let me go back and include stop words. Okay, now I'm able to reproduce what Mickey has. Yeah, so words like stop, problem, service, year, return, replacement, batteries, battery, Amazon, warranty, batteries, replacement. So yeah, if I look at that first topic, maybe a little difficult to derive semantic understanding of what that topic is. Maybe same thing with battery replacements, right? Topic 1, as Suleiman points out, seems to be about images. Right, zoom, focus, lens, cameras, right? The topic of cameras. So generally speaking, what we've seen so far in these reviews is there's topics, there's documents that talk about maybe replacements and battery replacements, right? Reviews talking about maybe how they replace the batteries quite often. Some reviews that are dealing with language of cameras. Let's look at topic 2. Speaker, Sony, noise, ear, comfort, headphone, music, ears and ear. So this here appears to be perhaps audio, right? Audio topics. So notice how there's some onus on us, right? There's some cognitive load on us for us to derive these semantic understandings, these semantic meanings. But nonetheless, see how it's created these groups, how it's identified the dominant words that contribute to a new topic, a new feature. Look at this one here. Monster, short, picture, long, printer, connector, length, extension, Belkin, signal, monitor, TV cable. A little not so clear to me what that semantic understanding is. But printer and maybe something with printing? Who knows? Not so clear. Let's look at 4. Tripod, Kodak, zoom, photos. Once again, another topic that deals with cameras. Audio, CDs, VCRs, Memorex, recorder. Media, right? Media files or media. Audiovisual media topics. That's not too bad, right? That's pretty impressive. It's all supervised, unsupervised learning, by the way. We have learned to find new features in our data that are composites of my old features. Questions people have? Okay. So that takes care of this optional question, right? So it's a little difficult to grade, right? So it's not a requirement. But now we know how to do topic modeling. All right. Anything else people want to talk about with this mini project? Right, we're done. Anything you want to bring up about the NLP mini project? Okay. Well, if there are further questions on the NLP Minute Project, we're done with it, right? Maybe this one would be a good candidate for lemmatization. Yeah, maybe so, yeah. I kind of agree with you, Renato, right? We probably should do some lemmatization. Why not, right? Why not? Why not? Let's do some lemmatization. Let's try it out, right? Let's try it out. I like that idea. Let's improve our results, right? Let's never satisfied. We're never satisfied, right? So let's try that out. Let's try that out. And what I want to do there is I'm going to define my lemmatize function. Lemmatize. And if I recall, it's going to accept a document. What I want to do is I want to use spacey, or I want to use spacey. Import spacey. Yeah, never surrender. Thank you for trying to push to do a better job. And we're going to load, here's how you do it, the NLP pipeline. But what I want to do is, lemmatization can be rather slow. Lemmatization can be rather slow. But there are ways we can speed things up. So this NLP object in spacey represents a pipeline. In fact, right, we can look at documentation, spacey, spacey NLP. All right, get started. Let's see. What it is, this NLP object represents a series of steps, kind of like we have this idea of a transformer series of steps, vary so much in this NLP object. It goes through a tokenizer, a tagger, a parser, an entity recognizer. But we want just simply the lemmatizer, because we don't care about, at least initially for us, tagger, the parser, the entity recognizer. We don't care about those steps. We just want the lemmatizer. So what we can do is we can disable certain parts of our pipeline. So it's going to be a lot faster to run. So let's go ahead and do that, because it will speed things up as we go through. So let's try that out. So here I'm going to say disable let's disable the parser, the entity recognizer, the tagger, and the text categorizer. We're simply disabling parts of our pipeline so it can be a lot faster to process, because we don't need those steps just to lemmatize. And this will accept the document. And what I'll do there is I'll say, okay, for Word, an NLP document, what I'll do is I'll iterate through for the word, pull the lemma, and we'll lowercase the word. And we'll return that to our user. Let's see. Okay, let's try it out. Let's try it out, right? We have our reviews, data polarity. Let's look at one of those reviews. It's one of those reviews. Let's feed that into our lemmatizer. All right, that seems to work. Seems to have worked. Okay. So we got our lemmatizer. And now the next thing we do, since we want to use stop words, we got to make sure we lemmatize our stop words. A little subtlety here, but the way that stop words are removed is they happen after the tokenizing step in scikit-learn. So any type of, when we have stop words and we do lemmatization, we need to lemmatize our stop words. So let's try that out. I can say for word in stop words, I should, let's see what happens if I feed if I feed my lematizer my stop words. Let's see what happens there. We had a type error because it wants a string. Oh yeah, it wants a string, of course. No problem. So say for stop word and stop words, what we'll do is we'll lematize our stop word. And I just want the lemma attribute error list. Let's see what's going on there for stop and stop words. Oh, forgot. I want to do NOP. There is the lemma of my stop words. I believe it's the lemma of my stop words. I'll make sure we're lowercase it just in case I have any uppercase characters. And just compare with my stop words. Let's see. Looks like they're in alphabetical order. So became, because, become, which is B. Right, there it is, B. Oh, actually become. So looks like lemmatization did work. So now let's go ahead and move on. I'm going to call this stop words lemma. Since I want it as a set, there it is. So now I got my stop words lemma. Let's go ahead and finish up here. So stop words lemma. Followed by the tokenizer with my lematizer. Lematize. Let's try that out. It's going to be a little slower because lemmatization takes some time. But how I'm lemmatizing my words, let's see how much better I get. Right? We observe, right? And this is one of the things we want to do, right? We don't necessarily want to build the most complicated model right away. We want to build something simple. We learn when we build something simple. One of the things we learned is that, hey, a lot of those common words are the same thing. Let's look into lemmatization. So let's see how much better we have. Our strategy is to always generate value. Okay, a little weird how I actually have more words now. Oh well, it's a little weird. Let's see what the results come out. Let's choose topic 0. Some punctuations. Right, I have some punctuations now. Problem machine delivery computer, home hope support, record. This one here is clearly camera. But notice when I look at my results, I have these punctuation marks. I probably don't want that. I don't want those punctuation marks. In fact, there's probably several ways I can go about doing this. I can go back to my lematizer, my tokenize function, right there. And what I can do is I said, you know what? Let's go and first clean up my document. Let's go and clean up my document. So what I'll do is I'm going to use a regular expression. I'm going to say doc clean. I'm going to import RE, import the regular expression library package module. And I'll say RE find all. And what I want to do is I want to find everything that is, I want to find all my words. I don't want any kind of this junk that might occur. Okay, so let's go and play out regex 101. What I'll do is I'll look at one of my sample documents. copy this, paste it there. Let's go to Python. Now I'm going to say my regular expression will be the following. /b stands for assert a word boundary. So there are boundaries that can happen between words, like spaces, punctuation marks, an empty space. This meta character B represents those word boundaries, anything that could be a boundary between a word. So what I want to do is I want to look for a word boundary, followed by a character, by a, as I call a match any word character, as it's called. Then what I want to find next here is I'm going to look for, let's see, and then what I want to find next is any word character and any apostrophe, and that will occur one or more times. So what I'm essentially looking for is what's going to happen. I'm going to have a word character. What will follow next is either a word character or an apostrophe that will occur one or more times, and then I have a word boundary. So notice how it's not going to pull out those numbers. It's not going to pull out numbers. It's not going to pull out punctuations. So this is the regular expression I'm going to use here. I can come up with a different regular expression, but this is what I came up with now. Word boundary, followed by a word character, followed by either a word character or an apostrophe that will occur one or more times, followed by another word boundary. I'll copy that, and that would be my regular expression here. And since I have an apostrophe, I'll just switch this to double quotes. And there's my regular expression. I want to apply that to my document. Find all will give me an iterable, I think a list of everything I found, and I will proceed to join them on an empty space. So this will represent my cleaned up version of my document. Doc cleaned. There are various ways I could have cleaned it, but this is the way I chose it. And now let's process that doc clean. And what I'll do is I also want to make sure that my word lemma, the lemma of my word, is not in, I don't like an underscore, I don't like a period mark. I should not actually capture those things, but oh well, let's see just in case. And any kind of pronouns. Actually, my cleaning should not have that issue, so I can probably say make sure word lemma is not equal to a pronoun. This here is the lemma of a pronoun. Let me just double check that. No, let's see, what is that? Guess I'm wrong there. Actually, let's see what happens. Maybe I disabled too much stuff in my pipeline. Yes, I did. I disabled way too much stuff in my pipeline. Let's see. I might need to tag her. I disabled way too much stuff in my pipeline. There we go. I goofed. I disabled way too much stuff in my pipeline. So now I can just disable these three things, and I have something that appears to be lemmatized. Okay, I probably had a broken lemmatizer before. And, alright, syntax error, because I'm missing the ending there. Just space this out. What I'm essentially doing, not documents, but document. Document, okay, thank you, right there. Alright. What I've basically done is I've cleaned up my document string. Then I went to lemmatize it and make sure it's not a pronoun. Well, this probably should have been a stop word, right? We're filtering here. The role of a stop word. Let's just do that in the stop words. So I'll make sure I include the pronoun. Okay, so there's my lemmatizer right there. And now let me go ahead and create my stop words lemma I think now they're actually lemmas. There you go. Pronoun. Okay. Now I think it will work. All right, in retrospect, it was kind of obvious I messed something up. Should have followed my gut. Had some intuition I did something wrong and messed up my limitizer. I disabled way too many steps in my pipeline. Right? This is why we check things. We make sure things make sense. Right? Be critical of our work. One of the things that helps is be critical of what we get out. Let's be critical. Let's not be enamored too much with the results we have. Let's be skeptical and let's probe to really gain confidence of what we're building. It's a little slow. It's what's slower, substantially slower because I am doing lemmatization. But hopefully I finally will have the better results. The results we need, right? Not be satisfied. Improve on our approach. Improve what we got. Questions right now. I know I've been going a little fast here and there. But general questions, things we want to bring up. Did it run? Did it run? Did it run? Yeah, I think it finished running. All right, let's see what results we got. There we go. Notice how there's less words, right? Less features. Makes sense, right? Makes sense. We're lemmatizing. We'd expect that if we were to lemmatize certain words like run and runs and ran would have been distinct features are now the same. So before that wasn't the case, and that should have been a smell. That should have been something that was off and fishy about our code, but I ignored it, right? I did the bad thing. I saw that was a little weird, but apparently I said, oh, I didn't make a mistake, right? I was a bit arrogant there. Now this actually matches up what we expect. To have less features, which is something that makes sense when we lemmatize. All right. Should have been more critical, but oh well. We recovered. We're improving. And now let's see what happens if I look at my new topics. Topic 0. Let's start at topic 0. Let's examine the results what we got. Job, quality, compatible, advertise, describe, customer, review, Linksys, tech. Not so quite clear what that semantic understanding is. Let's move on to topic 1. Low, 200, shot, portrait, wide. Oh, clearly this is our camera topic. Phone, set, headset. Noise, Sony. All right, audio, right? Audio. Headphone stuff, right? Headphones topic. I think our features, our words are a lot cleaner now because we have the lemma. Hook, connection, short, end, maybe extension. Another topic that's going on are conversations about extension cords, wires, cables. Another topic that's going on. Topic 4. Come, lens, image, features, film. Once again, something with cameras. That's fine. We get repeated topics. Movie, prom, Memorex, video, DVDs, TV, burn, MP3s. Oh, okay, cool. I think I'm more satisfied with my results. But now that we've actually built this, right, what use would this be? Right? We don't want to do things sort of in a vacuum. Right? We do data science for us to do something, not to say positive, but there's a motivation behind this, right? There's a purpose behind what we do. What do you think would be a usage or a purpose of what we've done here? Identify topics in our reviews. How would you do this? Let's go ahead and be creative. What can we do with what we built here? think about this as at least what I'm thinking of now. Maybe I can do this to learn, if I fail to have a new document that isn't really one of these topics, then maybe there's something, maybe I can discard it or something like that. Or maybe when someone's writing a review, or maybe I can use this to kind of suggest tags, right? Imagine if I were to do this on our forum, our question board forum. Or if I do it with enough questions, I might learn what are certain topics being discussed on the forum. And then one of the things that people don't do so well on the question board is properly tag their posts, right? I'm not gonna lie, people probably don't always properly tag their posts, but wouldn't it be nice to have an automated system where someone starts writing out their post and it determines the topic of their post and suggests tags for their post? Yeah, I can definitely see us building something like that here. All right. I think that finally wraps up all the mini projects. Anything we want to bring up before we conclude? We'll have to do something interesting tomorrow. But I got a couple of tricks up my sleeve. Yeah, exactly. As Renato says, right? When you post on LinkedIn, right, you offer the most common tags. Exactly, right? You can imagine, on a high level, they probably built this technique, right? They're probably using these techniques. Probably maybe fancier things, but ultimately, this is what they're doing, right? We've learned how that can be built now. So hopefully the creative juices are going now as we go through the curriculum. All right. Well, tomorrow, I got a trick up my sleeve for tomorrow. How about that? Got a trick up my sleeve for what we'll do tomorrow and the next week or so. With that said, everyone, take care. Have a good rest of your day. We'll see you back here tomorrow.